Good morning, afternoon, or evening. How you all doing today? Welcome back. Happy New Year, by the way. We're going to continue with Chapter 4. Yesterday we reviewed the difference between a relation and a function. We reviewed how to graph a linear function by making a table of values. You choose independent x values. We call them the moral 5. Okay. We use the moral 5 always unless there is a fraction being multiplied to the variable x. In that case, you choose x values that are multiples of the denominator to keep your life easy and in integer form, no fractions. We also talked about standard form, which is ax plus by equals c. And we spoke about both the x and y intercepts. The x-intercept is the x value when y is 0, and it's on the x-axis. And the y-intercept is the y value on the y-axis when x is 0. Once you have found the x and y intercepts, you can graph those ordered pairs, connect the two dots or ordered pairs, and you have your line. So today, we're going to start taking a step towards an easier way to graph, and we're actually going to start learning the real mechanics of a line and why is it steep, why is it not so steep. All of those good things come from today. And today's lesson is called the rate of change and slope. All right. Well, what is a rate of change or slope? Think about ski slopes. Okay. When you're skiing down a ski slope, okay, let's say here's a little mountain. All right. They have categories for these ski slopes. I'm not a big skier, but I know there's things like the red line or the widowmaker or the diamond, and they have different categories depending on the slope. What does slope mean? Well, what they do is they take a point up top on the mountain, and then they take another point down at the bottom. And then they calculate, okay, what is the slope here? What is the rise over run? I'm going to go down a vertical line. I'm going down vertical. And then I'm going to go over in a horizontal direction. They connect these two dots. And not only do they create a triangle, but they have created what is called the slope. Okay? Or the rate of change. The slope or the rate of change is the ratio of the vertical change. Vertical is either up or down. Okay, that's vertical, up or down. So it's the ratio of the vertical change. It's the change of the dependent variable. That's the y values. Over the horizontal change. The horizontal change is this guy right here. Horizontal goes left and right. Okay? And it's the change in the independent or x values or variables. So slope or rate of change is the change in y over the change in x. It's the change in y over the change in x. The only difference between slope and rate of change is that rate of change actually involves units, like feet per second or miles per hour or whatever, days per month or, money earned over time. Okay, rate of change is the same thing as slope except they have units. Now, how do you find this rate of change or this slope? Well, slope equals either a rise over run or a fall over run. Let me explain the difference. If you notice that the rise, I have a plus sign. And for the fall, I have a negative sign. Well, it's very easy to understand this. You rise if the slope is positive. You fall if the slope is negative. But regardless of if it is positive or if it is negative, you always run to the right. You always run to the right. So again, slope is a rise over run. If the slope is positive, you are going to rise. If the slope is negative, you are going to fall. Okay? However, you always run to the right. I'm going to explain that now with some examples. As far as a formula goes, my friends, the slope, which is represented by m, where is it represented by m? In the slope-intercept formula. Y equals mx plus b. Remember, we've talked about this bad boy already. This m is the slope. And you find the slope by using the formula y2 minus y1 over x2 minus x1, where x1 and y1 and x2 and y2 are two different ordered pairs. And one thing about slope or rate of change, it is constant throughout the line. That's why it's a slope belongs to straight lines. You can't curve or all of a sudden jump up a whole bunch or go down a whole bunch. It is constant. Okay, the slope of a line is constant throughout the whole entire line. So far making sense? Okay, let's continue. Why don't we find the rate of change and listen to what I put, or read what I put in parentheses. Please remember that the rate of change is the same as slope, except it includes units of measurement. So in this case, we're going to find a slope, but it's a rate of change because I have units of measurement. So, if you remember, my friends, time is always independent. Time is always x. And in this case, distance in feet is y. So, label, and plug in the formula. This is x1 because it's my first x value. This is y1 because it's my first y value. This is x2 because it's my second x value. And this is y2 because it's my second y value. So let's find the slope, or the rate of change. It's y2, which is 520, minus y1, which is 260, divided by x2 minus x1. So 520 minus 260 is 520. No, it's not. It's 260 feet over 1 minute. Yes, sir, you had a question. Thank you, sir. And that is my rate of change. It is the same thing as slope, except it has units. Now, what does this tell you? What this tells you is
That the skier should have been 260 feet.
every minute you're going up 260 feet. This would not be good for a skier because skiers are going down, right? This is a positive. So whatever is happening, maybe it's a ski lift, maybe. Good job. Well done. Way to think. Good job. What it's telling you is whatever you're on, regardless if it's a ski lift or a train or a car, every minute you're going up 260 feet. Every minute you're going up 260 feet. And that's what the rate of change is telling you. Does that make sense so far? Okay. Now, I did it all by hand, but I also wrote it out for you guys. Remember to always find the independent and dependent variables first. Remember what I said, time is always independent. Okay, then label your x1, y1, x2, y2. In this case, time is x and distance is y. So I have the formula that I already showed you how to do. And the slope or the rate of change, remember, is constant throughout its own linear equation or function. That slope will never change in that particular equation. You with me, guys? Yes, sir. Thank you. Of course I would want you to, it's not that I want you to label feet a minute. If I ask you for a rate of change, it's a rate of change because of the labels of the units, sir. Thank you very much, sir. Anything else, guys, so far? All right, good stuff. Now, there are 4 kinds of slope, guys. Why is this important? Because if you're trying to figure out a slope from a graph, or figure out a slope from some points on a graph, or figure out a slope from just looking at the equation, which is very easy to do as well, you want to know which way that slope is pointed. Okay? First of all, whenever you're looking at a graph, you always read the graph. You read, just like a book, from left to right. Okay? You always read from left to right. So a positive slope, if you look from left to right, it's increasing, correct? So a positive slope increases from left to right. A negative slope from left to right decreases. Okay? Negative slope decreases from left to right. A zero slope goes directly through the y-axis at whatever point it is instructed to do so at. This particular graph would be 1, 2, 3, 4. This is a y equals 4 graph. If you guys remember, we talked about those. When you have no x, that means that your slope is 0 and you are going through the y value that you were instructed to do so. Undefined is the reverse of the zero slope. There's no y value here. It's just going up and down. It's a vertical line going through the x-axis. The equation to this particular one would be x equals 1, 2, 3, 4, 5. There's no y because the slope is undefined. And a little note here, the slope of a line becomes steeper as the absolute value of the slope increases. What does that mean? If I take this graph here, okay, let me get one of these graphs. Okay. It says that if the slope becomes steeper as the absolute value of the slope increases. Well, let's think about this. Let's do y equals x. The equation of y equals x would look like this. Now in red, let's do y equals 2x. The slope is increasing. So now my graph would look like this. See how it's a little bit steeper? You see that, guys? Let's do it in green now. Y equals 5x. You could really see the difference. And this would be my y equals 5x. So if you notice, the larger and larger the absolute value of the slope becomes, the steeper and steeper the graph becomes. Does that make sense so far? Awesome. May I continue?
Yeah.
Awesome. Thank you. So, what is the slope of each given line? Okay, you got 2 beautiful things here. Okay, 2 ways to do this. You can, first of all, when they give you a line like this, you can simply, literally count. You find the furthest point to the left, and then from left to right, you figure out what rise did I do and what run did I do to go from one perfect point to the next perfect point. So the first perfect point on the left is right here. Okay, that point is -2, -1. What did I do from this point? How did I rise and run or fall and run to get to this perfect point over here? What did I do there? Yes, sir. Very good, son. I went up 1, 2, that's my rise, and I ran 1, 2, 3. So my slope is 2/3. Now, it's positive, so it should be going up from left to right. This line does go up from left to right. We're golden. Now, remember how I told you that the slope was constant? Let's find the next perfect point. I'll do it in green so you can see the difference. This is where we were. Now let's go up 1, 2 over 1, 2, 3. Look at that. Works out perfectly. How about this one? Down 1, 2 over 1, 2, 3. Works out perfectly. The slope is constant throughout the line. That makes sense so far, guys? Awesome. Okay, now, for this next one, first of all, is it going to be positive or negative right off the bat? Negative right off the bat because I'm going down from left to right. Here's my perfect point. So in this case, I want to go to this next perfect point. So I'm going to go down 1, 2, 3, 4. So I went down 4, so I'm going to go negative. Remember that if you rise, it's positive, but if you fall, it's negative. So I went down 4, and I'm going to run 1, 2, 3, 4, 5. Down 4 over 5. So my slope here is negative 4/5. Is this making sense, my friends? Okay, awesome. Yes, sir. You don't need to identify them because I had already identified them for you. But let's talk about this for a second because that's a very good question, okay? Let me erase this. If I were to just give it to you like this or on an SAT, if they were to do that, let's see if I can make this work a little bit better for you guys. Let's see. Okay, let's look at the perfect point here. Okay. Do you see exactly where the perfect point is? It's right there. You see that? It's kind of like, you know how the games you play, the Army games or Black Ops or all that stuff, and you're a sniper, right? I'm not trying to be violent or anything, but you're a sniper. You want to put the head right in between the crosshairs, right? Well, think about it like that. You want the point exactly in between the crosshairs. Not a little to the left, not a little to the right, not, oh, it's almost there. You want it exact. Does that help?
Yeah.
Okay. So in this particular case here, guys, this one is not exact. That's not exact either. The only one that's exact is that bullseye right there. Does that make sense? Promise? Okay. Thank you, guys. That's a great question. Thank you, son. May I continue? Thank you. Okay, next. What would the slope here be, my brothers? It is going to be negative. Negative 3 over 2 is exactly correct. I went down 1, 2, 3 over 1, 2. Negative 3 over 2 equals the slope. Fantastic. How about the next one, gentlemen? Up 1, 2 over 1, 2, 3. Rise over run or fall over run, 2 over 3. Excellent. Excellent. What's the slope of this bad boy? Vertical. That's undefined. Very good. Just for giggles, just to keep you guys going ahead of the time, what's the equation for this? X equals negative 6. Very good. Very good. How about this last one here? What's the slope there, gentlemen? 0. That's exactly right. And for giggles, what would the equation of this line be? Y equals negative 2. Very good. Excellent job, gentlemen. Excellent. Does that make sense so far? Awesome, guys. You're doing great. Now, remember we had talked about slope being a formula. It's y2 minus y1 over x2 minus x1. I'm not trying to bore you, but this is what 4 is. I promise you. I'm going to review all of this tomorrow with 4, but we are already doing 4 right now. I don't want you to think I'm boring you tomorrow. I just want to make sure that you guys understand this, okay? The best thing I can tell you guys is, like I've told you throughout for everything, label, thank you. Label, 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 label. I don't care which one you choose x1 and y1 to be. I don't care which one you choose x2 and y2 to be. It does not matter. I could call this x2 and y2 if I want, and I could call that x1 and y1 if I want. You're still going to get the same answer, I promise you. So I don't want you guys to stress out about that. However, I always like to go in order. So for me, Mr. Morrow, I find it easier. First point I see, that's x1, y1. And then, come on, Morrow. x1, y1. And then that's x2, y2. And now I literally plug it into the formula. y2 minus y1 over x2 minus x1. Please be careful with your negatives. 4 minus 7 is negative 3. And negative 2 plus 3 is 1. So my slope is negative 3 over 1. Yes, sir. What do you mean you're confused?
Under the negative 3 is x1.
This is x1, y1. And then this point here is x2, y2. I had to label my ordered pairs. So I saw the first ordered pair. I said, well, I'm going to make that my x1, y1. The second ordered pair I see, I'm going to make it x2, y2. Does that make sense, my man?
Yes.
Thank you, sir. Okay, next, B. Let's label x1, y1, x2, y2. y2 minus y1 over x2 minus x1. That's 0 over negative 7. What's 0 over negative 7? 0. Undefined is when 0 is in the denominator. Thank you. No need to apologize. That's why we're learning. Now, does anyone notice anything here? You don't see anything particularly cool here? The 0 is the numerator, but why is the 0 the numerator? Look at the two ordered pairs. Someone's got it. They have the same y. When the y's are the same, guys, you can save yourself time. The slope will always be 0. And when the y's are the same, that means that this graph is going through the y value 1 forever. So what kind of an equation would this be? Y equals 1. The slope is 0, but that's a y equals 1 equation. How come? Because 1 is the y value always, forever. Yes, sir. As long as the numbers are the same, the y value could be 5 or negative 2 or 17. But if the y values are the same, the slope will always be 0. Now, using that logic, what do you think would happen when the x's are the same? Thank you very much. Let's do it out so you could see it. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. That's going to be 4 over 0, which is undefined. That's my slope. Just out of curiosity, just for giggles, what would the equation for this be?
X.
The equation would be x equals 7. I don't know where you got 4 from. X equals 7 because that's the same x value forever. You guys with me here? If you're not, that's what I'm here for. This is my job and my pleasure. You guys with me? All right, cool beans. Now, your nemesis. I know, fractions. Ooh, too bad. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Okay, what do we have to find in order to add these guys? Common denominator, thank you. So this becomes a 3, this goes to 9. So that's negative 8/3 over, this denominator goes to 5, so that goes to negative 20. So that's negative 22/5. Please get that far with me right now, because I want to make sure you guys know how to do this like masters. You guys with me? Everyone understood that part? Yes, sir, my brother. How did I get the 9? Okay. Thank you. No. That's why I asked. That's why I asked. May I erase the work for C so I can... Okay. Thank you. All right. Let's take this and let's start all over again. So we got 1/3 minus 3, right? The denominator of 3 is a 1, right, my brother? So I want to get common denominator. So I want this to be a 3, so whatever I multiply to the bottom, I multiply to the top. So that's 9/3. 1/3 minus 9/3. Yes? Does that make sense? Finding common denominators. Talk to me now, guys. Because you're going to see this on quizzes and tests and homeworks and SATs. Yes? Cool. So now, how do I divide these fractions? Come on, it's a little song I taught you. Stay, change, flip. Very good. Stay, change, flip. Stay, change, flip. So, stay, change, flip. Okay, first of all, what's a negative divided by a negative? So those are going to become positives. 2 goes into 8 4 times. 2 goes into 22 11 times. 4 times 5 is 20 over 33. That is my slope, gentlemen. Does that make sense? Do you see how I did that with the fractions? So you have to review how to add and subtract and multiply and divide fractions. You have to, my friends, okay? You have to. E. See if anyone remembers anything that we just finished doing. What would the slope be? Undefined right off the bat. Why? Very good. The x values are the same. So if I did this, it'd be y2 minus y1 over x2 minus x1, which is 5 over 0, which is undefined. But as long as you see that the x values are the same, the slope is undefined. What's my equation? X equals 4. Excellent. Thank you, son. And then for f, what will my slope be? Slope is going to be 0 right off the bat. Why? Because the y's are the same. So what would my equation be? Y equals -3. Absolutely fantastic. Does that make sense, guys? Promise? Okay, good stuff. Now, real quick, just so you can see how this works in real life. Okay, in real life. I don't have the real life numbers, so I apologize for that, but I will tell you a very good example. We've all been on a plane, right? All right, well, I'm not a good artist, so, but you have this plane. I know. I don't even know what that looks like. Okay, here's the plane, and here's the little door, and then little windows, whatever. Okay, so you have this plane, right? And it's going to land over here. Do you think they just point down and say, gee, I hope I make it? No, it's not going to work out very good that way. So what happens is the air traffic controllers create a slope for them. They create a slope for them. Okay? And they have speed over distance. So the closer they get to the ground, the slower they have to get. Slope is used for many things, and this is just one of them. Okay? Yes, sir. Okay. Once it hits a certain point, the air traffic controllers have a GPS on them. And once it hits this point, they already know, okay, you got to start reducing your speed to this, and you got to start pointing down at this slope. It's pretty cool. Guys, thank you very much. Hope you learned a lot, and have a great day.